Wind turbines connected to the MPPT tracker of a photovoltaic hybrid inverter. Made possible by a new algorithm for true self-sufficiency, or simply as support for those times when we would otherwise have to draw electricity from the grid due to too few hours of sunlight. With this topic in today's episode, welcome to another video on this YouTube channel. More and more of my customers, subscribers, and channel members are now controlling their entire household via Home Assistant. If you truly want to get the absolute maximum benefit out of your photovoltaic system, then this is indeed the most sensible and remarkably easy way to effectively maximize your degree of self-sufficiency. That's why it has now become an absolute standard in the systems I implement. Home Assistant, especially when running with AI support, takes into account not only all the parameters within our household, but also those outside of it, ensuring that our energy is stored at the right time and made available again at the right time. Exactly where it makes the most sense, exactly where we need it. So more and more of my customers, subscribers, and channel members are striving for the highest possible level of self-sufficiency, and not without reason. Because staying permanently connected to the public grid is, as I have already announced on all my social media channels, becoming less and less attractive, and the grid operators have long since communicated that they want to mandate the ability to shut down our systems as needed. And if you think this is really only happening to stabilize the grids, I have to disappoint you. In my opinion, that's simply not true. Anyone who believes that still believes in Santa Claus because, let's be honest, there are hundreds of sensible and clean ways to stabilize the grid. In reality, it's all about business once again. Because as long as we buy electricity, the state makes money. If we supply ourselves, it earns nothing. Most people have understood that by now. Only the very last total fools out there just don't quite get it. They still truly believe that politicians, or let's call it the state itself, know what's truly good for us. That they inherently know what we actually need. But in my opinion, it's about gaining control over the citizens. It's about remotely controlling them. Anyone who has been paying attention in recent years, I won't say the word now because it messes with the YouTube algorithm, knows exactly what I'm talking about. Autarky, on the other hand, means freedom. And that's why more and more people are choosing exactly this path. But the big sticking point is often this. What good is the best control supported by the best AI to us? AlexGPT. If there simply isn't enough energy available, if the sun isn't shining, then even with the best photovoltaic system and the smartest control, we can't just magically produce electricity. Even more modules won't help us either. To be honest, it's worth nothing. They only offer a limited advantage because, as I've explained many times, the difference between sun and no sun is unfortunately very significant when it comes to photovoltaics. And that's exactly why we would need another energy source for those times when the sun just isn't enough. And that's exactly what a wind turbine could be. A turbine that could theoretically produce electricity around the clock, not just for a few hours a day. In most cases, even a small one is enough to compensate for exactly what we're missing. Up until now, though, it was quite complicated because there are hardly any approved wind turbine inverters for home use that are also capable of synchronizing, and most of them generally have poor efficiency. That's why many people say, wind power is like fishing. But in reality, the turbine is just what it is. It's a rotor that spins. What really matters is what happens afterwards, namely proper control or regulation. And that's exactly what we can now take into our own hands, because with our photovoltaic hybrid inverter, there's the option to define the behavior of the MPP tracker ourselves. Bear with me. I'm not going to mention any brand names anymore. You can find the best devices to realize everything I'm telling you about in my online shop. The link is below in the video description. This mode now allows for true MPP tracking for wind turbines, which can be adjusted to the characteristic curve of each specific turbine in accordance with the local wind conditions. In today's video, I'm going to show you exactly this mode. I'll explain what MPP tracking actually is, why it works completely differently for a wind turbine than for a PV module string, and why this new solution is simply better than anything I've seen so far. I will explain how a wind turbine actually generates electricity, what matters when it comes to the turbine and its settings, and which points you absolutely need to pay attention to. With that in mind, if you enjoy this content, share this video with your friends, become a member of my channel for even more detailed information, and use the time during the intro to scroll down, hit the like button, subscribe to the channel, and activate the bell. I'm Alex. Let's get started. But how does a wind turbine actually work? Obviously, everyone knows it spins in the wind and generates electricity. But what actually happens inside? Inside the turbine, there's a coil and one or more magnets. With a positive and a negative pole, the turbine spins and electricity is generated. Depending on the design, it supplies us with either single-phase alternating current or three-phase current. But be careful, we can't use this electricity in its current form yet because the frequency isn't right and the voltage isn't right either. And for the reasons mentioned, we also can't synchronize ourselves with the public grid. At best, we might be able to use it to power a heater or some, rustic lighting, but definitely not regular electrical appliances like the ones we typically use in our households. And just like with a PV module, the electricity doesn't simply flow out of the wind turbine, it has to be actively drawn off. And this happens, let me put it this way, with two components: a rectifier, which converts the AC alternating current into DC direct current, and a consumer that draws the electricity. And this consumer, once again, is the MPP tracker in our photovoltaic hybrid inverter. So how exactly does such an MPP tracker work? The classic maximum power point tracker in the inverter was originally designed for photovoltaic modules. Its principle is actually quite simple. It simply draws more and more current from the modules and keeps doing so until the module can't deliver anymore. And when that point is reached, it notices because the voltage collapses. At this point, it regulates itself and operates at this maximum power point. This works perfectly with PV because the voltage changes only minimally, even when the irradiation changes. What does change, however, is the amperage that we can draw from the module. And with a wind turbine, it's completely different. There, the voltage changes constantly, depending on how fast the wind turbine is spinning. This also means that the characteristic curve for a wind turbine is completely different. That's exactly why, up until now, you couldn't just connect a wind turbine to the MPP tracker of a photovoltaic inverter. And even after rectifying the current from the wind turbine, the voltage fluctuations remain. Whether it's single-phase or three-phase, you need to know that after rectifying from AC to DC, the voltage increases. With three-phase current, logically, it's more. With single-phase alternating current, it's a bit less, but the voltage increases because the alternating curves are essentially straightened out. This is important for determining the ideal voltage range. And in addition, wind turbines require a completely new algorithm. And that's exactly why some manufacturers now offer what's called a Wind-Turbine Mode. This gives us the ability to set the characteristic curve ourselves. That means we define at which voltage the MPP tracker is allowed to draw how many amps. All of this can be done in up to 12 steps or subdivisions between 120 and 600 volts. For example, we can say that if there are 200 volts at the rectifier, then draw 4 amps from the power generated. Or if there are 300 volts, then you may draw 6 amps. Or if there are 400 volts, then even 8 amps. And everything in between is logically and sensibly interpolated by the MPP tracker. This allows you to replicate the power curve of the wind turbine. The necessary information for this is provided by the wind turbine manufacturer, which we can then enter into the corresponding settings in the wind turbine module. How many amps a particular MPP tracker can draw depends on the inverter manufacturer. If you're interested, I can give you detailed information about which brands are capable of this and how much is possible with each device. Now it gets really interesting because we can also, and this definitely makes sense, adjust the power curve to match our wind conditions. Lower amperage at lower voltage means the wind turbine gets going earlier, so it starts generating electricity sooner. The downside is that the brake can kick in earlier as a result, and because of that, we lose out at the top end. A bit of peak performance, but just like with a bicycle with gears, the trick is to shift into the right gear at the right moment. And the great thing is I managed to get Home Assistant in combination with AlexGPT, my own AI system, to handle this gear shift automatically, intelligently, and perfectly adapted to the situation. And that's exactly the point why a wind turbine becomes incredibly interesting in this combination. Because we're no longer running the turbine according to the data sheet, but instead adjusting it precisely in real time via microprocessors to the actual conditions on site. Of course, this whole setup doesn't work with every wind turbine. We need wind turbines that, after rectification, even fall within the voltage range of the respective MPP tracker. With my inverter, that's between 120 and 600 volts. And as I said, the efficiency of the wind turbine is determined not only by its geometry, but also by its control system. The control system needs to know how many amps it can draw at which rotational speed of the wind turbine, meaning at which wind-defined voltage. And that's exactly where it fails in most cases. The inverter can't know that unless you program it specifically for the respective wind turbine, and also some kind of a run-of-the-mill charge controller doesn't know that either. Just like a photovoltaic inverter can't know what the weather is like outside. It has to figure it out through MPP tracking. With a wind turbine, it works differently. There, the power curve has to be matched and pre-programmed for the specific turbine. Many people now buy some random wind turbine off the internet, hook it up to some wind turbine inverter, often bought from Alibaba, that doesn't match the turbine, and then complain that wind power is useless. Or they buy high-quality components, but things still don't work because nothing fits together. And the wind turbine, after being switched on, either stands still or spins wildly like a washing machine when it starts to spin. The excess electricity is then even burned off by some people using so-called dummy loads through a resistor instead of putting it to good use. And that's why electricity isn't really generated efficiently in the process. So it's important, first of all, it's crucial whether the AC voltage at the turbine is even compatible with the MPP tracker. Basically, whether it matches which wind turbines this applies to. This information will soon be available in detail in written form in my YouTube community. It will definitely be visible to my channel members. There, I'll also show you how AlexGPT works. Based on your wind data from the EcoVid weather station, it calculates which wind turbine will run most efficiently at your exact location. It's not a gut decision, it's mathematics. And it's precisely at this point that all the amateurs differ from the professionals. And now for all the technicians and for you, you've probably already realized that this mode can be used not just for wind turbines. In principle, it works with any DC source, even with third-party batteries. You simply enter the voltage of the generator, or rather the battery, that you truly want to tap into, and then define dynamically and intelligently via Home Assistant precisely how many electrical amps may be safely drawn in which specific situation. In this way, I can also feed electricity from a long-term storage unit into the house grid, which, if not needed immediately, automatically ends up in our short-term storage. And this opens up completely new possibilities, namely to transfer electricity from a very large external battery into the short-term storage, or to charge cheap large-scale storage units over weeks in the summer and then use the electricity in the winter. You can integrate used industrial batteries, forklift batteries, or second-life electric car batteries. And of course also, a hydrogen system with an electrolyzer and fuel cell, which supplies you with direct current again during reconversion, processed through the appropriate power electronics. This is important, making it perfect for the MPP carrier in Wind-Turbine Mode. These are all things that are sometimes available used, often dirt cheap. The hydrogen system is, of course, an exception, but it works with classic PV technology. It was hardly usable with Wind-Turbine Mode. There it works. I've tested it and I know how it works. Soon I'll show you which characteristic curves I use, how I define them, and on what criteria they're based, and how these are then actually dynamically adjusted via AlexGPT and Home Assistant. If you enjoyed it today, leave me a like and share this video with your friends. I'm curious to hear your opinions and read your comments. I'm Alex, the one who won't let your power get cut off. That's it for today, and we'll see each other again in the next video.